What we have here is a block of mass 4 kilograms rests on a rough plane inclined at 60 degrees to the horizontal. It's connected by a light inaccessible string which passes over a smooth light fixed pulley of particle mass 8 kilograms which hangs freely under gravity. The coefficient of friction between the block and the plane is 1/4. The system starts from rest with the block a distance 2 meters from the pulley. The 8 kilogram mass moves vertically downwards. Show that the tension of the string is 52 newtons, correct to the nearest whole number. Okay, so it's not going to, the plane isn't going to move. Why is it? Why is it not going to move? It's not a wedge, it's a plane. Okay, it's not going to move. Okay, so the next thing we're going to do is we're going to resolve our forces. Now there's friction on this one, isn't there? So I think we're going to assume that the 8 kilograms wins out and drags the 4 kilograms upwards. Everybody happy enough with that? And if it doesn't work out that way, it auto corrects itself as negative answers anyway, so it's no big deal. So 4 kilograms. Okay, so what goes directly downwards, lads? Directly downwards? Anybody? 4G, directly downwards. What goes directly, perpendicular to the plane? R. And then going to work something perpendicularly down from the plane, and then we have parallel to the plane. We've made our gravity triangle. Okay, what angle is this here? 60 degrees, okay, so 60. 60 degrees, okay. Now that's done there. What can we say next, guys? We got to break it up into, that's, oh sorry, that it's 60 degrees here. Excuse me. Completely put in the wrong place. Everybody knows why the 60 goes there at this stage? If not, I'll remind you one last time. What you do is you finish off your triangle. That's 60. That's 90. Makes that 30. And if that's at 90 degrees to each other, makes the other one 60. Long story short, this one here always matches that one in there. Okay. So 4G cos 60 and 4G sine 60. Okay, so 4G cos 60, 4G sine 60, otherwise known as 2G, and so what's that? 2G and 2 root 3G. Everybody right with that? Now, we said the acceleration is going up the hill. What's pulling up the hill, guys? Pulling up the hill is tension. Bringing it down the hill, the 2 or 3G and friction. So friction equals mu r. Okay, what's mu? A quarter. What's r? R is in the opposite direction to the 2G, yet it isn't sinking into the plane, which means that it's going to be r equals 2G. Okay, so it's balanced. Okay, and then what do we get? It's going to be g over 2, isn't it? Or half g. Okay, so that's there is going to be a half g in that direction there. Now, next thing we got to worry about is the 8 kilogram particle. So the 8 kilogram particle is sinking downwards at 8g, and it's going up at tension T. Is that right? So T up, 8g downwards. Happy enough with that? Now, we said that it's going down at acceleration A. So therefore, for the 8 kilogram mass, we're going to have 8A going directly downwards. So lads, what goes here? T or 8G? Which one goes first? 8G, because it's going directly downwards. Take away the T, which is going upwards. Okay, and what about the equation for this one here? 4 kilogram mass moving parallel to the plane. So MA is the force. So what's MA? How heavy is the block again? 4 kilograms. So 4A going up the plane. What's the force that goes up the plane? Tension. Tension leads. What takes away from tension? 2 over root 3 G, and then my a half G after that. I have two equations, okay? Idea is to isolate one letter and then isolate T. So what I think I can do straight away is I think I can add the two of them together. Would be a good idea. So if I place them directly underneath each other and add them together like simultaneous equations, what happens here? 4A plus 8A, 12A. T takes away the other T, no bother there. And then we're going to have 8G minus 2 root 3G minus a half G. I'm going to need my calculator for that. Okay, so I'm going to have 8 minus 2 root 3 minus a half, which is minus 0.5. Then I'm going to divide all that by 12. And what I'm going to get here is 0.3363. Let's just overdo the decimals at this point. Did I divide by 12 that time? Yeah. So 0.3363G. 0.3363G. And to fix the G, I need to multiply by 9.8. And now what I'm going to get here is that there, but like 3.296. 296, rounded up. 3.296. Now, to solve the tension, just go back up to the top and use the 8G minus T formula here. So I'm going to get T equals 8G minus 8A. T equals 8 times 9.8 minus 8 times 3.296. Put that into the calculator. 8 times 9.8. I'll answer that question now. 8 multiplied by 9.8. Take away 8 times 3.296. Okay. And what do we get here? Uh, 52.032. T equals 52.032. There you go. So that's the tension to nearest hole. T equals 52 newtons. Any questions? I won't get rid of them too quickly. Okay, this part here is what I need. Move that up there and move everything else down. Okay guys, so what we're going to do next is I'm going to answer this one here. How far has the block moved up the plane after 1 second? Well, that's a UVAST. So UVAST. U being equal to 0, A being equal to, that's not G, it's just 3.296 and S minus 1. S we don't know, but T is 1 second. How far? So S equals UT plus a half AT squared. U is 0, yeah? So S equals a half multiplied by 3.296 and T squared being 1. Okay, then put that in to the calculator and what do we get? S equals 1.648 meters. Is that it? Okay, Now, I'm also gonna find out phi while I'm here as well. Okay, just might as well find out phi while I'm here, because it helps with the second question. Second question says, after 1 second the string is cut, determine whether or not the block will reach the pulley. Now, how far away was it from the pulley at the very beginning? 2 meters away from the pulley, and it's already covered 1.648 meters up. So it's basically moving. Upwards. Okay, and it ends up around here. All of a sudden, the tension is cut. So its forces have now changed. Okay. So what I'm going to do is I'm going to find out how fast he was going just before he was cut. Okay. So before it's cut, I can do 1.648. Phi equals u plus at. Phi equals 0 plus 3.296 times 1. Phi is obviously 3.296. Okay. So what happens next, guys, is that we used to have this equation for the... Oh, I ripped it out. I have it here anyway. We used to have the equation for the velocity of the 4 kilogram particle. The velocity of the 4 kilogram particle used to be like this. It used to be 4a, just from the last part, equals t minus 2 root 3g minus g over 2. Okay? Tension was driving it up. Its friction and its weight were driving it down. So this is the weight and this is the friction. What happens when you sever the link? Which one of them disappears? Tension has to disappear. Now all of a sudden your acceleration has changed. Your acceleration is now a deceleration. The minute you cut that link, you're no longer accelerating up the plane. You're now decelerating, because you're trying to use your momentum to get up the hill. You're going to stop, and then you're going to come back down again. So we have to find out what is this deceleration. So a is going to equal minus 2 root 3g minus g over 2 all over 4. Same thing as me doing this in the calculator. 2 root 3, minus 2 root 3 minus a half. One sec. Minus a half divided by 4, and then multiply the answer by 9.8. And I got answer very large, minus 9.71. Now guys, the reason why friction is continuing to work against it is that you're on your plane, okay, and you have your particle here, okay, and what's happening is the particle is actually still traveling up. The friction acts against its motion, not against its acceleration. Because it already built up momentum, it's still rising up the plane. Then it's going to stop. Then it's going to start falling. Only when it starts to fall does friction reverse direction. Is that alright? So, our acceleration, we found out to be, when we put this in the calculator, minus 9.7. Is that alright? Very big acceleration, but you also got to remember it's a friction assisted acceleration. So minus 9.7, and that's the minus 1. Now, does it reach the 2 meter mark? How much distance do you have left to reach the 2 meter mark? Sorry? So 2 meters minus 1.648, which is equal to 0.352. Do you reach the 0.352 mark? That's what we're trying to figure out. Okay? You've asked. Can anybody tell me what is our velocity when we reach the top of the plane? So what is the velocity at our maximum height? Our final velocity will be 0 just before we start to fall backwards down. So velocity will be 0. Our initial speed, 3.296. Our acceleration, minus 9.7. Question is, will our S value be bigger than 0.352 or smaller than 0.352. So let's find out what S is. V squared equals U squared plus 2AS. Phi squared 0, so it's 3.296 squared plus 2 times minus 9.7 multiplied by S. Bring this out to your side, we're going to get 2 times 9.7. S equals 3.269 squared. S therefore equals 3.296 squared divided by 2 times 9.7. So 3.296 squared divided by 2 multiplied by 9.7. And the answer is 0.56. So S equals 0.56. 0.56 is bigger than 0.352. Hence, it will reach the top.